A rock thrown upward with initial velocity of v naught equals 64 feet per second from an initial height of h naught equals 80 feet follows an equation for its height in feet as a function of time. Y of t equals negative 16t squared plus v naught t plus h naught. Determine the parts A through F. Our position function of time here, the height in feet as a function of time, is negative 16t squared plus v naught, which is 64, times t, plus h naught, which is 80. For part A, the velocity is a function of time. It will be the derivative of the position function of time, so y prime of t. The derivative of the first term is a power rule, bring down the power, multiply with the negative 16, subtract 1 from the power. The second term is a constant times t, the derivative will be the constant. And the third term is a constant with no t, the derivative will be a 0. There's our velocity as a function of time, negative 32t plus 64. Part B, we want to know the time when the velocity is 0, and therefore we can take that velocity expression we just found, set it equal to 0, solve for the t. Let's start by subtracting 64 from both sides. Now we'll divide both sides by a negative 32, giving us negative 64 over negative 32, which is a 2. So our t is going to be 2 in time units, can be found over here in the initial velocity per second, so we're in seconds here. T equals 2 seconds. Part C, we want to know the maximum height reached. The maximum height will be reached at the instant in time when the velocity has become a 0, because the rock at that instant is turning around from having headed upward to now starting to head back downward. And so we found that turnaround time, the time when velocity is a 0, in part B, we found to be 2 seconds. So the maximum height will occur right at that time, y of 2. Plugging 2 into the y, the position function, we will have a negative 16 times 2 squared plus 64 times 2 plus 80, which gives us negative 16 times 2 squared is a 4, plus 64 times 2 is 128, plus 80. Negative 16 times 4 is negative 64, plus 128 plus 80, adding those together would give us 208. And so 208 minus 64 comes out to 144. Our units for a height will be in feet, we can see over here, and the v naught or the h naught, we're in feet. 144 feet. For part D, we want to find the time when it reaches the ground. The ground is defined as a height of 0, so we're going to take the height function of time, the y of t, and set it equal to 0. Negative 16t squared plus 64t plus 80 set equal to 0. And we want to factor this. Let's start with a common factor. There is a negative 16 that can factor out of each of the terms. That'll leave us a 1t squared, a minus 4t, and then a minus 5. So we have a trinomial to factor here. So we have negative 16 times, we'll factor into t times t, and then we need two numbers that multiply to be negative 5 and add to be a negative 4. It sounds like negative 5 and positive 1 will take care of that. So we have two solutions, t equals 5 and t equals negative 1, but times can only be positive numbers, and therefore we're going to only keep the 5. It looks like it'll reach the ground at a time of 5 seconds. For part E, we want to know the velocity when it reaches the ground. Well, we just found the time when it reaches the ground, so that could be plugged into the velocity function found in part A. So we will want v of that time we just found, 5 seconds. That will be negative 32 times 5 plus 64. Negative 32 times 5 is negative 160 plus 64, which will give us a negative 96 units of feet per second. The negative indicates headed downward when it reaches the ground, as it should be. And then part F, we want the acceleration as a function of time. The acceleration is the derivative of the velocity, which itself was a derivative of the position. Therefore, we have the second derivative of the position. We have the velocity function in part A, so if we take the derivative of that, the first term is a constant times t. The derivative will be the constant, negative 32. The second term is constant with no t. The derivative will be a 0. The units for acceleration are going to be the length, units of feet, over the time units squared, so feet per second squared. Negative 32 feet per second squared.